Let's consider the tree below. Suppose we designate vertex E as the root. We're told to list the children, parents, and siblings of each vertex. Then, does any vertex other than E have grandchildren? And notice how I've circled the root E in red. For a quick review, if two vertices are adjacent, then we say one of them is the parent and the other is the child. The parent vertex is always closer to the root, and the child is always further away. Siblings are vertices with the same parent. Siblings are never adjacent, and a grandchild is a child of a child. So going over to our table, let's start with vertex A. Notice vertex A and vertex B are adjacent. However, vertex B is closer to the root. This indicates B is the parent and A is the child. Because there are no other vertices adjacent to A does not have any children. Let's go ahead and enter none. Again, the parent of A is B. Notice B is the parent of the vertices A, C, and D, which indicates C and D are siblings of A because they share the same parent. Next, we have vertex B. Vertex B is adjacent to vertex A, vertex C, and vertex D, but vertex B is closer to the root. This indicates A, C, and D are all children of B. Notice B is also adjacent to E, and since E is the root, E is the parent of B. Notice E has two children, B and F. This indicates that B and F are siblings, or we can say F is a sibling of B. Next we have vertex C. C has no children. The parent of C is vertex B. C and B are adjacent, but B is closer to the root. B is the parent of C. And we just said A, C, and D are all children of B. This indicates A and D are siblings of C, again because they share the same parent. And now we have vertex D, which has no children. The parent of D is B, and the siblings of B are A and C. And now we have E, which is the root. E has two children, B and F. Notice E is adjacent to B and adjacent to F, but E is the root, and therefore B and F are children of E. A root never has a parent, so that's none. And because the root E doesn't have a parent, it also can't have any siblings. Next we have vertex F. Vertex F is adjacent to G, H, and I are further from the root than F, indicating G, H, and I are children of F. The parent of F is the root E. And because both B and F are children of E, B and F are siblings, we can say B is a sibling of F. Next we have vertex G, which is adjacent to F, but F is closer to the root, indicating F is the parent and G is the child. Since G is adjacent to no other vertices, G has no children. The parent of G is F. And notice F has three children, G, H, and I, which indicates H and I are siblings of G. Next, vertex H has no children. The parent of H is vertex F. And the siblings of H are G and I because they share the same parent. And then finally, vertex I has no children. The parent is F, and the siblings are G and H. And for the last part of the question, does any vertex other than E have grandchildren? Notice E does have grandchildren, actually has 6 grandchildren because A, C, D, G, H, and I are children of E's children. There are no other vertices that have children of children, indicating only the root E has grandchildren. It is the only vertex whose children have children. I hope you found this helpful.